Good afternoon. We are going to present a paper titled Predictive Simulation for Building Trust within Service-Based Ecosystem. The paper is a joint collaboration of CNR East Italy and Fraunhofer IESE Germany within the European project WIECO. In this presentation, we are going to introduce the context and the problem, then the predictive simulation and runtime monitoring approach adopted, and finally we conclude by describing an application example and possible research directions. When joining an ecosystem, various actors such as developers, organizations, and users can create together innovative businesses. In an ecosystem, actors have collaborative and competitive goals and work together through complex relationships. In the context of autonomous vehicles, actors' interaction is realized through provision of software components. A typical extended cloud-based vehicle is schematized in this figure. Typically, software solutions part of an extended vehicle are hosted in the cloud by third-party providers. And besides the party providers, these services can be accessed by additional users as well. This aspect significantly increases the risk for malicious attacks. This risk is due to the fact that cloud services are executed as black boxes and can be accessed by third-party applications which are themselves executed as black boxes and can potentially contain malicious behavior. Emerging technologies within the automotive industry allow traditional vehicle manufacturers to keep up with users' demand at a rapid pace. For assuring the safety of technology integration, a number of standards provide specific guidelines. Such guidelines are particularly targeting design techniques and interfaces for governing and harmonizing the development of the new services. Despite the guidelines and specifications provided by the reference standards, due to their complexity, extended vehicles require additional security measures. This becomes even more critical in the case of communication-based extension and remote connection, where design time undetected vulnerability make their way into runtime system operation. In this paper, we propose an approach for building trust in the execution of black box service-oriented approaches that connect to safety-critical systems. Building the ecosystem trust within an extended vehicle is typically the outcome of testing activities performed in a testing environment during design time. With our concept, we move forward the trust evaluation process towards runtime by exploiting the simultaneous digital twin execution. In the figure, a digital twin of a service, part of an ecosystem, is the machine-readable representation of its behavior. For creating a holistic evaluation scenario, digital twins need to be evaluated in relation with their interacting entities. Within a predictive execution environment, the digital twin can then expose the malicious interaction and possible vulnerability threats before they occur in the real world. This will enable a safeguarding of a trusted system execution. The predictive simulation environment is used to assess the trustworthiness of an interacting service. The execution of the digital twin provides a projection of service behavior for a sequence of requests describing an evaluation scenario. Different approaches such as combinatorial testing, for example, the pivotal proposal, or fuzzy testing methodologies can be used to create situations in which violations or malicious behavior can be experienced. Within this process, the collected digital twin responses are compared against a virtually derived interface of trust. Then, within a conformity monitoring process, the execution of the real service is compared against the virtually validated digital behavior. For the creation of runtime trusted behavior signatures, the execution of the digital twins results into a sequence of requests and responses which are fed into an internal validation engine. The order, the type, and number of events then forms the service interaction valid signature. The monitoring engine then compares predicted behavior to actual behavior. when, for example, the predictive simulation supported by design time evidence invalidates a sequence of requests and responses, malicious behavior triggered by specific sequences is detected. As part of future work, we aim at defining digital twins for web services as precisely formulated sequences of events that, through dynamic execution, enable a simulator to possibly create predictable artifacts based on model execution. Further on, because virtual evaluation is realized using virtual entities communicating with each other through virtual signals, and because the behavior model of each entity represents an abstraction of the system behavior, we will investigate on developing mechanisms that ensure the detection of maliciousness during a system virtual execution. Thank you.